Hey, hi everyone. If you are someone like me living under the rocks, you would have not heard Florence too. I think it got released few months back and it has become really popular. In the last video, I was doing how to fine-tune Flux model, and for image captioning, we used Florence 2. And I was also researching on SAM2 how to run it on Jarvis Labs. Then I also looked at references of how Florence can be combined with SAM2 to use ticks for doing segmentation. So this all kind of made me curious. What does Florence do? When I read about it initially when it got launched, I thought it's another model. Let's not worry about it. As so many models are getting open source today. So in this video, we will actually look at what is Florence do, what all it can do. A demo of that. There is a notebook which will look at it. There's so many examples in it. We'll look at some of the examples. One of the things that I was really interested is the data set. The way they created the dataset is interesting. What is not interesting is it's not open source. The model is open source, the dataset is not open source. I hope Microsoft does that. And there are people who are requesting for it. Yeah. Please release the FLZ.
So, but like one interesting thing, Vishnu, I just want to add it here. So they created dataset using open source dataset images, but they didn't release this dataset as open source. This kind of not make sense.
Probably we have to look into the paper more clearly to understand if they just use the data set of the previous open source, or did they do any addition to that. We'll look at, probably we can actually do a separate video on that part. But the interesting part is the data set is not manually annotated. It uses all the previous machine learning models or AI models to annotate that. We'll get to that. The architecture, the best part of the architecture is its simplicity. We'll look into it. And the key capabilities. And the last part of the video is, if you have not subscribed to the channel, please subscribe. Please do. It will really help us to make more videos. And we promise you this time we are going to keep us. Okay. So let's get into what is Florence 2. The best way to understand it is it's a function, large function, which can take image and some text as an input. And then it can output one of these, right? Depending on the text prompt. Let's say, for example, you say, I want a caption, it's going to generate a caption. If you want a bounding box, it's going to do that. If you want a segmentation, it's going to do that, right? That's what it's capable of. Let's look at the demo. How do you run that? To do that, Hugging Face has this repository. You need a instance with a GPU. I'm not sure if it runs without a GPU. It's a small model, but not too small to run on a CPU. Maybe it'll take a lot of time, right? So we pick the smallest one. You can either pick RTX 5000 or A5000. I just pick A5000. Pick something like 100 GB. Again, I hope you know what is Jarvis Labs. We make it super simple for you to get started with AI model training, deployment, and serverless. And our instance launch times are super fast. We have been working on this in the last few weeks. And this instance gets started in less than 5 seconds. It's actually 2 to 5 seconds. But on the safety side, I'm saying it's 5 seconds. As you see, it's actually less than 5 seconds, right? Once the Jupyter Lab is done, what we will do is we will use Hugging Face as a GitHub repo by clicking this and say clone repository. And put this here, terminal, and paste it here. So we get a first to large repository. When you have model weights, you can use this technique, but one challenge with that is if there are different variants of model weights like safe tensor, the binary, or FP16, FP32, you end up downloading all those weights, so you have to be careful with that, right? It's getting unpacked. Let's wait for a second. Actually, we're not going to use, from this notebook, this is to show you how to set up if you want to run it, right?
Actually, it got...
Yeah, it's going to run me. So inside this repository, let's go and look at sample inference.ipynb. It needs 2 additional libraries or 2 or 3 additional libraries to run it on Jarvis Labs. When you actually do it on your machine, it could change. Some of the libraries that you need to install is Matplotlib. It's very unfortunate we don't have it in Jarvis Labs today. But probably by the time you see the video, we'll try to see if we can add it as part of the base image so that you don't need to do it. Add this, run the installation, and that's it. You don't need to do anything else to try out this notebook, okay? which is the installation is going to take a few seconds, and the model download is going to take probably a minute or so, which is all going to happen automatically, just like if you're using a Colab. JupyterLab works similarly. In this instance, there's another instance which I have already downloaded so I can experiment with it. Let's start with what it's capable of, right? We're taking this particular image. It can do a bunch of tasks. I can actually do a lot of tasks. So when I was actually doing the notebook, I kind of got lost. So what I did is I kind of took these notes, right? This is like probably an annotated version of the notebook where I say, okay, what is this particular cell, right? We can just collapse all these things. The way I try to understand is through this cascade tasks. Okay, so it's basically these particular two are in one category where things don't need any additional input. You just tell a small kind of a text thing saying that I want a caption, I want a detailed caption, I want a more detailed caption. This is something which I found it funny. Probably A needs more fun and object detection, more things. And the second set of things is where it's slightly different. You still have these tags, but you have additional inputs like where do I want this object to be? Or you want to find out what object is that in a particular coordinate, or you want to find out or segment a specific object. Let's say in this photo frame that you see, where is the mic? Then it probably segments this. It finds this object here, right? It can do these things. And there is also OCR related task. We will get to those things. Let's look at the some of the examples here. So we have taken this image as an input and we say caption it. It says a green car parked in front of a yellow building. Next one is detailed caption. It makes it slightly elongated, gives more descriptions. This is actually useful probably when you're doing something in the image space.
Correct.
For example, in the last video, we were showing how to fine-tune a flux model with AI Toolkit. In that example, you just upload the images and we use Florence 2 model to actually generate probably something like more detailed caption or a detailed caption. You can play with it very quickly. That I think one of the most powerful things with this model is that. And object detection is going to find out the objects. That's more interesting. The region proposal is finding where the boxes are, which contains an object. The next one is with additional inputs, right? So this is with some difference, which says, you say this particular tag, right? This is a text prompt. Basically, you combine these two, text prompt and text input. Then a green car parked in front of a yellow building, right? So it's going to just find a green car and a yellow building, right? So here we are basically adding more thing, but its entire thing, everything is just a text, right? Only these things has a special meaning to it. Otherwise, you can just add text. Let's say this example, let's say wheels. I don't know what is going to happen, but let's try. Nothing wrong in trying.
Yeah.
It finds wheels. It doesn't find the car anymore, right? So you can just play with it, simple text. And there are more examples. And there's also examples for segmentation. Another interesting thing is the OCR related task. Let's look at that. So probably this is one of the most simplest books to read, Coda for engineering, and most easiest subject to read.
Yes. Not a promotional video. Not sponsored.
I heard actually good things about this particular book, but CUDA for most of the engineers is usually hard. I think Jeremy Howard of Fast.ai and Answer.ai tried to make a video on CUDA simplifying it. I tried watching it, but I could not complete it. Probably I will finish it someday and I'll understand how to write a code in CUDA, but today I'm not capable of that. So this particular model, what it does is, let's come back to the video, it finds the varchar boxes and text, but we tried it with different images. It's not that accurate, but the good thing about this model is it's also good with fine-tuning. Okay. We'll get to that in a moment, right? So these are some of the capabilities of these models. So let's go to our notes. I had to take notes to make sure that the video is in a proper structure and I don't miss things. The paper has actually so much of information. The initial idea was to actually do a paper walkthrough. Then we thought to keep it actually as probably 2 or 3 parts, not even a separate video, 2 or 3 videos dedicated for that. I'll explain you what I mean by that. The data set, right? We'll see what is the data set that's used for this thing. it uses 126 million images. The beauty of that, as Tamim was mentioning in the start of the video, is these are not new images mostly. I just want to confirm it.
Yes.
What is new is the captioning or the annotations of the video, of the images, right? They use different models from the previously released to create annotations. What we mean, we can see that at the end of the paper. Let's come in the reverse way, right? These are the results from Florence too. Let's look at annotations. Let's go to the top of the annotations and do it. Okay, these are some of the annotations. More examples of annotations, right? So you pass the same image. Let's look at just this image, right? We'll just look at in the y-axis, vertical. Here it just finds the boxes where the human is, his hands are. Then you go with regional phrase. Now you're adding for the same image extra annotations where you say, the first one is region proposals, where it's just a box. The second one is the box along with the name associated with it. The third one gets more interesting. You don't just associate a classification kind of thing, dog or cat. You also say probably something like, hey, this is Jack Russell Terrier. This is Albert Einstein, right? Here it's Albert Einstein. And this, it's not just a quote. It's a quote from Albert Einstein. That's what makes it interesting. Then read the brief text combining these two. Basically, the same image is being fed into multiple models like classification, object detection, create a caption of it. And now these becomes annotations for this new model, right? That's what makes this thing interesting. I think this is not going to be very complicated. Even if Microsoft does not create this data set, I think the open source community would probably create this in the coming weeks or months. If some of you are already working on it, please let us know. We will also see if we can participate in that part of it. Next one is the model architecture. If you're already into transformers, you know a lot of concepts like embeddings. The best part of the architecture is super simple, right? Let's start with the input. It's the image or text. Convert that into encodings, image encoder, text encoding. Combine them, concatenate, and pass them to an encoder. Encoder, decoder, sequence to sequence architecture. And then you have the standard 4 or 5 outputs. You have the same loss function. In fact, the beauty of this entire architecture is so simple that whatever you learned in the previous models, you can reuse it here. I keep on jumping into the next topic, so I kind of want to stop. Let's look at the key capabilities. Or is there something you want to add in this architecture?
Basically, it's a transformer architecture. So it kind of like gives you 4 or 5 different task outputs. So basically,
it's a caption, object
detection,
and this is the
location, like the bounding box location.
It's not just bounding box, it's bounding box and the text associated with it. It knows like the woman riding a bike is actually associated with this box. It's called the reasoning or something. I'm not sure what the exact English phrase for that. It's like a small caption. This is a segmentation, right? So every image, the model is trained on generating these things. So that's the reason it's like getting really good at it. What are the key capabilities? Zero-shot learning. The model is really good at doing things on which it is never trained. And this model also acts as a foundational model. That's where some of the interesting things happen. If you look at the LLM space in the last 2-3 years, it's become the common way to train a foundational model on unsupervised data, where they prepare the predictions as if the next word token. The same way in this model, they did not manually annotate it. They use the models to create the predictions and create a foundational model which is not good at one thing, which is like a general thing, which can do a lot of different things, right? This foundational model itself is good at predicting a lot of things on which it's not trained on. And that's what they showed the results in zero-shot learning. The second one is fine-tuning. Once you fine-tune this model on specific tasks, so they take all this COCO data sets and all these things, and fine-tune on that specific data set, of course, the training one, and they see actually it performing better than some of the models that are fine-tuned for that specific use case. And it is also mentioned that it's good for fine-tuning, and we have been hearing in the community that it's helping them a lot. Probably we'll make another video on that. So before winding off this video, let's go and look at the experiment section where they speak about these capabilities. Okay. So this is where we were telling that we evaluate zero-shot performance of our method on various tasks to show its inherent capability to handle multiple tasks without any extra fine-tuning. And the other thing which I was talking, there's a table which compares it with two models, Flamingo, Cosmos, and Florence 2 itself available in two different variants. One is 0.22 billion model, very small in today's world.
Base version.
0.77 billion model, not bad. Even the smallest LLMs are now in range of 7 to 8 billion useful models. So this is like super useful. This is again going back to what AI used to be 3-4 years back. And as you can see the results, these are like super competitive or way better than the models which are specified to this. Again, this is published on the paper, independent. But I think the best way to understand whether a model performs really well or not is to wait. If people are using it, saying good things about it, that means it's usually good. And this particular model has that particular characteristic. Is that something which you're missing?
Like mostly we covered all the things. In upcoming videos, we dive into the more technical paper and all the stuff, so you can understand more better the architecture and things.
So in case if some part of the video is not clear, or you're trying Jarvis Labs, you're stuck somewhere, you need help, you can join our Discord channel. You can let us know what you want, and we're happy to help. And if there's any particular topic on which you would like us to make more videos on, please let us know in the comments. We will check them and make it. And thanks for watching till now. I hope you find the video helpful. See you. Bye-bye. Subscribe to Jarvis Labs.